Hi, this is Epic M Studios. Today I'm going to do a video that's a bit different. It's something that I've been working on for the last 2 weeks. I guess you could call this a devlog. Um, I've been working on a tiled engine, not a, yeah, sort of a tile game engine. This is in the early pre-alpha stages, if it even gets finished. Um, it's got some very simple physics, really buggy. Like, I can show you a couple bugs. Let's see. Yes, you can go inside of the collision tiles, which are these fully gray ones. That is a bug. Um, and also like that. But, overall, it's okay. It's not using the tiled map editor. It's not using box 2D or anything. Yeah. The physics, I'm probably going to use the LibGDX rectangles and just see if they overlap. Because right now I'm doing a ton of math with the positioning of things. Let's see. This is a physics. It goes, yeah, it's like 150 lines. No, not 150. That's 50 lines, sorry. Yeah, math. Yeah. But anyways, it's not working as well as I planned to do, and I think it would just be a lot simpler just to use the libgdx is overlap instead of having booleans that are like this or even longer. Let me show you how I'm storing the tiles. And also, this has a cool map editor too, map editing function. So I'm gonna open it back up, and I'm gonna make a new map. Okay. So this is a map editor, and let's just make a map, not make. So I'm gonna. It doesn't have a GUI. It's very basic, but it works. I think it's simplistic, it's efficient, all that good stuff. But yeah, so like I said, it's a native file format for the map storage. It's not as compressed as the TMX files would be, but it is plain text. Not plain text. It's not just that. You can actually read it and get information from it. It's not base 64. I think the TMX files are base 64 encoded. Anyways, yeah, we can add one of these, and we can add. Anyways, just making a map in the editor. The only reason I made this editor was because it would take a way longer time just to do it in a text editor, just putting in all the values. And I have a setup it has basically each block of each type. So you have, like, say, metal. That's a material. But then for each metal block, you get like a ramp in like the top part and the collision part and all this stuff. It's confusing. I mean, not if you understand it, but I think I already did that. I think I'm done with this one. So, okay. Hit Shift O. What file would you like? Oh wait, no, I don't want to open. I want to save. Okay. Shift S. You must first choose a file to save to. What would you like to save to? Let's do map 2. Alright, I'm not going to put a file path, the actual thing, because my program already does it, because it's easier to do it that way. It just adds it on. So map 2. and then we're gonna have to do Shift S to finally save it, and in here it should say writing map. Yeah. So let's X out of that. Just get out of that. And I'm gonna go to here. So let's hit ls, and you can see we have map2.map, and I'm gonna open it. Map2, and you can see it's this it's ugly looking, but it works. And so the way the parser works, right? First, you give the size of the map, okay, which is, this is a 32 by 16 map. That's just what I set it to, what I had it preset to for the map editor. So it says, okay, if you, the parser says, I don't know if this is efficient, but if you have a number sign, alright, then after the comma, you'll have the X size. Then after the next comma, you'll have the Y size of the map for blocks. And then there's for air, it's just a bunch of zeros if there's like no tile there after that. And if you have a dollar sign, that means that there is going to be a tile, that like this whole thing is a tile. It's separated by spaces, by the way. So this is a tile, and so after it finds that it's a tile, it'll look after the next colon, right? And then that'll say the material that it is. All of these are the same material. It's kind of that same gray thing, the metal type thing. The textures aren't, that good. And then it'll say the type of block. So this might be a corner piece, and this will be the top side, and I think this is the right corner piece. But anyways, so it'll keep doing that. So you have 1-9, 1-6, 1-3, 1-2, 1-8, and those correspond to, right here, tiles.xml. Right? These correspond to a bunch of tile IDs. So the type of block is 1, right? You can see that here. 1, right, for all of these, since it's the same material. And then it has coordinates, right, and IDs. So 1-1 would be at coordinate 1, 2, 3, 4, 5, 6, blah blah blah. And so that I could make it so I didn't have to put like two-dimensional coordinates like 1-1 or 1, 1. What it's doing, it's saying, okay, I have a 16 by 16. It's actually 256 by 256, but the tiles are 16 pixels by 16 pixels. Sprite sheet. And, well, yeah, tile, map, sheet, whatever you want to call it. And so, the first one, the coordinate 1 corresponds to, let me go into my paint actually. Discard this. Okay. So you have the sprite sheet, right? And that's divided up, and this is a horrible drawing, into a bunch of things. So let's say we have a 4 by 1, 2. Let's just make that 4. Yeah, this is messy. Okay, if you have a 4 by 4 grid, alright? So the sheet is 4 by 4. This is 1, this is 2, 3, 4. Then we're going to go back this way to 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that makes it easier on me. All I have to do is count. I just have to say, okay, 1 plus 4 is 5, since it's the 4. So basically it's also easier for the parser, just makes it one step easier. That's the only reason I did it that way. Yeah. So the parser reads it, and each of these tiles also has a different set of information. It has the collision information. Right now in the early stages, the only ones that I have set to collide, since I haven't implemented like the ramps yet, are the gray blocks. So if we open it, are these gray blocks right here. Alright, those are the only ones. So it's not colliding with these or anything. I haven't implemented those, so yeah. There's a lot of code here, so I'm not really gonna explain it all. You have a block class, and each block class, I don't know if this is the best way to do it. I'm not an expert programmer by far. So each block has an array list, and that is for all the tiles. So if we have the tiles.xml, say we have a block, okay, class block, and it has an array list of all these different tiles, right? And so, oh, that's okay, yeah. Tile.java, alright, has 3 pieces of information. It has the coordinate, it has the sprite, which will be the sprite sheet, yeah, and the Boolean collision, alright, so true, false, if it collides or not. So that's pretty simple. That's how I did it. Player, sort of the same thing, except it for the player physics, I'm going to get rid of the I'm going to get rid of the collision detection and stuff for the player that I have currently. But the physics, I just have these equations. Yeah. I'm pretty sure they're correct. It would be pretty embarrassing if they weren't. I don't know. But so basically what it does, it has the player's position here. I'll make this blue so I can see. This might be wrong, by the way. Player's position here. Alright? And it has the force of gravity and whatever force you apply to it. Right? And it also has the velocity that's already going at. Right there. So we're going to calculate the acceleration first. So that's the sum of all of the forces acting upon it. And what I implemented in the code was every time I'd tell it to move during the loop, like say you're jumping while pressing the right arrow, that would add 2 forces to it, and also gravity. So I made an array list of vector 2's. I could have done an array, but an array list is better for that. So I made an array list of vector 2's, and the vector 2's are like how much on the y-axis, how much on the x-axis do you want to move. I'm not going to do direction and size of the vector, or not size, the length. I found it was easier. It was easier just to do it the XY way. But so I did that and divide it by mass to get the acceleration. Then velocity. The next velocity is, so it's the existing velocity plus acceleration times time. Time being the time step. In my case, I don't know what I put down there. You can do anything. It's more accurate if you have a smaller time step, but it's slower. And then the position. So the position vector is the existing position plus velocity times time plus the acceleration times time squared over 2, or acceleration over 2 times t squared. Yeah, pretty simple. Alright, so next let's open it. So I'm gonna go to my mapreader.java class and just change that to or no, I have the file in here, so file in the game level class should be, if I can find it, it might be in the show. Show, come on. Okay, no, I'm just saying get map, so get map is probably, yeah, as you can see, I need to get more organized with my code, a lot more. Mapreader. Alright, so read map. Oh, I think get map might be here. Sorry if this is confusing. Get map. Okay. Yep. So let's make it okay, level 2, I guess. Int level, so that'll be in the show. Level equals, you know what? I'm just gonna say get map. I'm gonna change it. So let's just make it map 2. And let's load that and press P to play. And you can see that's the map that we made before in the level editor. Yay. Got the player sort of glitching on it. But as you can see, the level, it's kind of the just level storage and opening is working pretty well. It's really flexible, and I like the implementation of the map editor. Anyways, yeah, I probably won't be releasing the source code for this if I'm going to use it for anything commercial in the future. Thank you for watching. Goodbye.